Hello, welcome. Let us talk about making gears. Tinkercad.com is a nice website to do 3D design, and they actually have a couple of gear design options on their website. So get into Tinkercad.com. It's free, you just need an account. And it opens up in basic shapes, which you'd be adding onto the work plane to make whatever you want to 3D print. But let's scroll, let's click on the drop down menu and come down to shape generators and go to all. Now, most recently, it was on page 3 that we had some gears. So they have a couple different ones here. This little gear, a pro gear, useful gear, and they all have some slightly different features to them about what you can pick for your criteria, depending on what you want to do. I wanted to make gears that I know would, well, that's a lot of criteria. I don't know if I want to play with. I wanted to simply make some gears that I could mesh, that I could do into a spirograph kind of thing, make a gear wall. So I ended up using the useful gear. And what I think I found out is that pitch is going to be the dimension I want to keep the same between gears of different sizes, of different number of teeth, in order to have them mesh. So, for example, I'm just picking a pitch of 2 here, and it had 20 teeth. Height of 20, okay, that's easy to adjust with on Tinkercad. Now, if you're going to 3D print these, just be aware that the larger you print, the longer it's going to take. So be aware of that. I would think to stay within 3 to 6 millimeters, 1/8 inch to about 1/4 of an inch is what you'd want to play with. And 5-10% infill would be fine. All depends on how sturdy they need to be. If you're actually using them in machinery, you've got to go with that higher infill, 15, kind of 20 even maybe. So this is a pitch 2. Number of teeth is 20. These are important criteria. Now, this option also allows you to have a bore in the middle for an axle. So if you want to put these on a dowel rod, or like if you're making a gear wall, they need to be on something so they can rotate. And this is right now in millimeters. Again, in Tinkercad, you can edit your grid and change it from millimeters to inches. Update your grid. And let's see if it, hey, look at that. Almost 1/4 of an inch. Pitch is now 0.08. Because the pitch is a combination of circumference and number of teeth. So because the dimension changed from millimeters, centimeters, millimeters to inches, that's going to change the number. But again, you just want to make sure that your pitch is the same for other gears. So I'll put a second gear up here with the same criteria, except I will change number of teeth. Now you could use the slider, or you could click on the numbers. I'll just pick 40. And notice how the gear changes size. So now I think we can see that they're probably going to fit in mesh. That's something to fiddle around and play with the experiment. I got to print some of these and cut some out of a laser. So obviously, being in Tinkercad 3D Design, I could 3D print these. Again, I need to make sure my numbers, if I want to 3D print, I don't want to be thicker than 1/4 of an inch. So I need to get my ruler over here and see what that dimension is. Oh, that's 0.354. That's way too thick to print. And I would find this. Yeah, 3/4 of an inch. That would take a long time. As I said, between 1/8 and 1/4, so 0.125 to 0.25 would be good. Or if you're in metric, 3 millimeters, 6 millimeters. So there, I could export the STL file, and I could print those. Now, the other option, which is nice with Tinkercad, is you can export an SVG. And this SVG I would use in a laser design software, laser cutter software. I have Lightburn. You could bring that SVG into CorelDRAW if your laser uses CorelDRAW. And it should just straight import and show up as an outline and be perfectly ready to laser cut. So there is gears in Tinkercad that you could 3D print, or you could export them for cutting on a laser. I'm going to cut them on a laser, much quicker than 3D printing. Wood or acrylic. Now I got choices. Thanks for listening. Bye.